Hello. In this section of snubber circuits part 2, we would like to discuss about the snubber circuit used in an inverter. We have taken an inverter circuit here. The drive, of course, is given from some digital circuits where we have the square wave pulses given to one MOSFET here and the other one with the inverted type. That means one is complementary to the other. And then we have a center tap transformer where we have these two windings and a primary winding or the secondary winding at a higher voltage winding. This is the basic snubber circuit where we have a diode here and then capacitor, resistor, and similarly on the other side. Let's try to understand how it works. We have provided deliberately a switch here so that when we switch off the snubber circuit, that means we disconnect the snubber circuit, we'll see what happens if the snubber circuit is not there. And if it is there, then what's the difference? So for that, now let's try to understand what happens while the circuit is in operation. Now let's see, while this MOSFET is conducting, because the positive may be appearing here in the square wave pulse, positive half cycle is coming here. With that, this MOSFET will conduct and the battery power will now flow from here through this coil and then go here and then comes to ground. So this positive half cycle is conducted. But the problem happens that while this is switched off and this goes to switch on, while this is getting switched off, the energy which is stored here or the current which was flowing in this direction will expect that energy to flow in that direction also, since this is switched off. If this is switched off, there is no path here. So the current will be now flowing through this diode and then charge this capacitor, and then that energy which was there inside the coil, this coil, after switching off, is dumped onto this capacitor. And in the next half cycle, when this conducts, during that time, this is discharged by this resistor, and same thing happened for the other half cycle. Another half cycle, when this becomes high, this conducts means this goes this way, this will find the path, this path and not this path. Similarly, when this current was flowing in this direction, this being a shorter path, the RDS of this is very low, so the current will typically flow in this path and not flow in this path. It will flow in this path only if when this is not conducting, and that time this current passes here, charges the capacitor, and in the next half cycle while this is conducting, this discharges by this resistor. Now this is what is the arrangement, a practical arrangement. This is the most practical circuit which is provided as a snubber circuit to protect the MOSFET or whatever active device here. Otherwise, there will be heavy voltage swing on this. Now let's see how it works. Now we will switch on a CRO or a cathode ray oscilloscope, and what we have done, we have taken the output from the transformer, and then we will see how it behaves while we switch on. Now we switch on this, you find this is the kind of waveform that we get. There is a little spike here because the on-off action takes place. This spike can be controlled also by using some voltage dependent resistor, but otherwise this is not very dangerous because the time period is very small here. But while we don't have the snubber like this, you see what happens to the waveform. The waveform goes haywire. A tremendous amount of noise which is coming, and that would kill the device if it is not taken care of. So this is what is the problem while you do not use a snubber circuit. Now if I put the snubber circuit back again, what I find that the waveform is so clean now as far as the square wave inverter is concerned. Thank you.